Hello, and welcome to the video portion for the first lab of ME 123, an Introduction to Visualization and Computer-Aided Design, or CAD for short. Today, we are going to begin our quarter-long tutorial of SolidWorks, a popular 3D modeling software developed for engineering purposes. The skills we develop in this software can be transferred to other similar software, such as Autodesk Inventor, Creo Parametric, and CATIA. For those of you who already have some parametric 3D modeling experience, the first few labs may be a little bit slow, but I still recommend paying attention. You never know what details you might have missed the first time around, and we teach some methods that might be new to you. SolidWorks has a variety of file types. The one we'll be focusing on for most of this quarter is the part file type. As the name implies, this file type is focused on developing individual components, or parts. The assembly file type allows you to combine multiple part files to create a more complex mechanism. Assemblies allow for motion between parts. Finally, there is the drawing file type, which allows you to produce a diagram to display your part or assembly in a two-dimensional format, often used for manufacturing in a machine shop. A good way to think about it is through a Lego analogy. Part designs individual bricks, assemblies design the box sets, and drawings produce the instruction manuals on how a set is put together, or they can show the dimensions of an individual piece. Let's learn about file management first. Up at the top left is the New File button, fairly self-explanatory. To the right of that is the button that allows us to open other SolidWorks files, similar to opening Word documents. To the right of that is our Save button. Make sure that you save your parts in a safe place and to use the naming conventions available on the syllabus for all SolidWorks assignments. Save frequently. SolidWorks does crash on occasion, and it hurts to have to start from scratch. We're going to be starting simple with a part file to show off the basics of producing geometry in SolidWorks. First, we can create our new file by selecting the New File button, select Part, and then hit OK. This brings up our main interface, and we have a lot to look at. Up at the top of our screen is the ribbon, which organizes a lot of the common operations that you would perform. Starting from the left, we have the Features tab. Features generate three-dimensional geometry, and we will be spending a majority of the quarter going over these tools, so I'm going to leave this be for now. Next up, we have the Sketch tab. Sketches are how you generate two-dimensional geometry in SolidWorks, and most features are based on at least one sketch. We will be spending most of this video on the Sketch tab. Next up is the Evaluate tab. This tab has a lot of analysis tools that let you ask SolidWorks about your model. We will be providing more information about these tools later on in the quarter. Most of the rest of the tabs are for SolidWorks add-ins or other tools. The first two are going to be the only ones that we focus in on. Over at the left side of our screen, we have the Design tree. This is a list that shows every operation that we've performed in the current model so far. Whenever you create a new sketch or feature, it shows up in the Design tree. You can access and edit previous sketches and features by selecting them from this tree. Finally, we have these miscellaneous buttons below the ribbon. We will be introducing these as needed, but if you hover your mouse over them, they give a quick description of what they do. One important thing to do is to make sure that we match our document units to the units that we want to work in. One way to change the units is through the Options menu up here. On the Document Properties tab, we can modify our drafting standard, which is usually going to be set to ANSI for the purposes of this course, and we can modify the units down here. Of course, there's a faster way that you can modify the units, and that's through the little drop-up menu in the bottom right-hand corner. You want to make sure that you choose the units that you want to work with before you start anything. This is because SolidWorks always thinks that you're intending to work in the units that it is set to. For example, if you start your sketch in inches and set a line to be 1 unit long, and then switch to millimeters, SolidWorks will convert the distance from inches to millimeters, leaving you with a line that is 25.4 units long, which may not be what you intended. The best way to avoid these kinds of problems is by starting your new document in the desired units. Let's get started with our very first sketch. To begin a sketch, select the Sketch button on the left-hand side of our Sketch tab up at the ribbon. From here, we must tell SolidWorks where we would like to sketch. You can sketch on any plane or a flat surface. You can also select the plane first and then hit the Sketch button. The two methods are equivalent. We don't have anything to work with yet, so we'll select a plane from our 3 default planes. I'm going to start drawing on the top plane. When we start the sketch, SolidWorks reorients our view to be looking directly down upon the sketch surface. We also notice that a new sketch has been added to our design tree. We are currently working in Sketch 1. While we are sketching, we can create some basic two-dimensional shapes by selecting the tools from the ribbon. Here, I've selected the Line tool by left-clicking on the button. Lines have a start point and an end point, so we can left-click to place the start, left-click to place the end, and then SolidWorks draws a line between the 2 points. While using the Line tool, SolidWorks assumes that you want to continue drawing lines. Sometimes this is a good thing, but at this point I'm done drawing lines, so we can deselect the tool by left-clicking the button once more, or by hitting the Escape key on the keyboard. Whenever SolidWorks is giving you a hard time with a tool, just hit the Escape key a few times, and that usually fixes the problem. While we're moving our cursor around the screen, I have a few other things that I want to bring to your attention. Down at the bottom right of the SolidWorks window is a pair of coordinates that shows our approximate location on the plane that we're sketching. These are based on the standard XY coordinate axes centered on the origin here. The small arrow points in the current X direction, while the large arrow points in the current Y direction. We can use these coordinates to place sketch geometry in approximate locations. In the next video, we will be detailing how to set and enforce specific dimensions and locations. But for now, these will do a good enough job in helping us get an approximate sketch down. Back to the sketch tools, there are a variety of 2D primitives that we can select from. Each one comes with its own rules and options on how to make them. Let's start with the circle tool. When you select one of the more complex tools, we see that we have a new menu over on the left. The circle type section shows us the different ways that SolidWorks allows us to define a circle, with the numbers indicating the order that the points are selected. For a generic circle, you can select the midpoint first by left-clicking, and then click again to set the extent of the radius. The other option allows us to draw a triangle. SolidWorks then generates a circle that hits all three of our points. We can go directly to our alternative methods by hitting the drop-down next to the tool. As you're sketching, you may fill up the screen or find that you need to sketch in an area that you can't see. This brings us nicely to how you navigate SolidWorks' interface. We have three main tools: Zoom, Pan, and Orbit. Zoom does exactly what it sounds like it does. You can scroll on the mouse wheel to get closer to or further from the objects on the screen. Pan allows you to move which portion of the screen you're looking at. You can do this by holding down the Control key and the mouse wheel. It should make a clicking noise, and then dragging the mouse around. Our last option is Orbit, and this allows you to look around the object from new angles, and it is done by simply click dragging with the mouse wheel. This option makes a lot more sense when we have 3D geometry to work with, and will be reviewed again when it becomes relevant. However, in our current case, this does leave us in an awkward position. We can't see our drawing very well, which makes sketching kind of difficult. In order to reorient ourselves, we have several options. You can click on one of the arrows of the triad, the coordinate system at the bottom left of the screen, to look directly down the selected axis. We can also change our view orientation by selecting the View Orientation button and choosing our desired view from either the table or by clicking from the view cube. Finally, if you want to focus on a particular sketch, you can right-click on the sketch and select Normal to. This will always orient you directly to the best viewing angle for that particular sketch. Anyway, back to sketching. There are a variety of tools, and the best way to learn is through experimentation and exploration. I recommend playing with each one of them to learn their strengths and weaknesses. While you are sketching, whenever you close a shape, or draw a shape that perfectly encloses an area, it will shade the enclosed area with a blue fill. This will only happen when a shape is perfectly closed, so if any endpoints don't exactly match up, it won't count as a closed shape. You can deselect your tools via the Escape key, and left-click drag to reposition endpoints to match them up better, which may fix the issue. This also does not work if there are any overlaps or crosses in your line. Something like this, for example, would not end up being shaded. These types of sketches are considered poor design practice and are to be avoided. A list of best design practice concepts are available on Canvas, and I would recommend reading through it to get a good idea of what is expected for full points on the assignments. Next up, we're going to hit construction geometry. Oftentimes, it can be useful to define things using other shapes, to show that several things are along the same line, or to use an arc or a circle to define some more complex geometry. The most common form is a center line or a construction line, which can be found in the drop-down next to the line tool. It functions identically to the line tool, and it will have more uses in the future. If you want to make construction geometry of a different shape, you can activate the relevant sketch tool, place it down, and then check the For Construction box over on the left-hand side. Importantly, construction geometry is not going to be used to define the actual boundaries of the shapes that you produce in sketches. It is only there to help you with positioning. It is very easy to get carried away with construction geometry, so I recommend that you use sparingly. The majority of the time, there are other options that can give you the same results and will leave you with a cleaner sketch. Another tool that can be helpful is the Trim Entities tool. This allows us to cut sketch entities up to the point where they intersect with other sketch entities, such as lines or arcs. Here we can see an example of how it works while using the Power Trim option. Simply hold down the left mouse button and drag to create a gray line. Once this line hits a sketch entity, it will cut it up until the point that sketch entity intersects with another sketch entity. This can be useful to close sketches or to make particularly complex shapes. One of the options for our trim tool is here in this box, which allows us to automatically change trim geometry into construction geometry. This can be helpful whenever you want to conserve geometric relations. While producing sketches, it is not uncommon to accidentally add an extra line or a bit of geometry while you're working. In order to delete sketch geometry, you can exit your current tool by hitting the Escape key, and then right-click on the sketch entity and select Delete. You can select multiple sketch entities by holding down the Control key and left-clicking on them, or by holding down left-click and dragging to create a box. Finally, to delete these entities, you can also hit the Delete key on the keyboard instead of going through the context menu. Last off, we're going to cover how to leave sketches. When you are finished sketching, you can select the Exit Sketch button up at the top left of the screen on the Sketch tab. Your sketch will turn gray, and you are no longer able to edit it. On occasion, you could accidentally get booted from a sketch. In order to re-enter the sketch, you can right-click on the sketch in the design tree and select Edit Sketch. This allows you to return to what you are working on. There are several ways to tell if you are in sketch mode, and inversely if you've left sketch mode. While you're in a sketch, the sketch button on the ribbon turns gray, the origin turns red, there's a sketch icon over in the top right-hand side of our drawing window, and the status bar at the bottom says that we are editing a sketch. Before trying to sketch anything, you can check any one of these to ensure that you are in sketch mode. If not, create a new sketch or right-click Edit the sketch to go back into the sketch that you are working on. That about covers everything that I had to talk about for today. Have a great day, and we will see you again next time.